On worksheet 5,
Oh, that's not.
omit 12 and 13.
Well, we're omitting it.
I mean, they're not bad. You set each piece equal to 0. That doesn't really work.
But we're omitting it.
It's just execution. And then you just test whether it's greater than.
And then you set up a number line and test positive, negative. Yep.
And it's weird because like.
That's not on the test or anything?
Not on the test.
And it's weird because the negative doesn't work because it can't be negative.
So put in 0, it's positive.
Right, so it's just B.
Put in 2, it's negative. So it's all of that. So it's B. But you don't have to do 12 and
And then
13.
13 was different because you have the x before the e.
Yeah, you'd have,
If x equals 0, then you have
and you'd have to test those intervals. See what happens.
I work.
But you don't have to do 12 and 13. That's very calculus type problem. We do this a bunch in calculus where we end up testing intervals. I'm doing that today in calculus. Okay, so other than 12 and 13, which you were supposed to omit anyway, my apologies.
10.
Number 10. Let's see. Okay, it feels like I should be able to get this to e to something equals e to something, right? Like same base, set the exponents equal to each other. Just an e sitting there, I'm going to put a 1 there. Just because that's going to make my life a little easier. So the left-hand side, I could rewrite as e to the negative 4x. And the right-hand side, like what's x to the 5th over x squared? Let's just get our brain remembering what we do with exponents here. How did you get x cubed? You subtracted. So what am I going to do with e to the 1st over e to the x? 1 minus x. So now I can say, all right, we're not canceling the e's, as much as you want to say that. We can set the exponents equal to each other. So negative 3x equals 1, and x equals negative 1/3. But that first step was the hardest, I think. Any others from the homework?
11. Dude, please.
Number 11. Let's see. Find the values of x to satisfy that. I don't like the denominator there, so let's multiply both sides by e to the x. That way we'll get rid of the denominator. And we have another an unintentionally nice thing about this problem. What does the right-hand side equal? 0. So 4e to the x equals 5. So e to the x equals 5/4. But then, now what? What do we do to both sides? This was the whole point of this lesson. Natural log both sides. And yes, natural log of e cancels, but what do we do before that? What was the whole point of natural logging both sides was to get that x out of the exponent. Natural log of e is 1. So x is the natural log of 5/4, which is d. Here. Number 9. Fractions. We don't like fractions, so get rid of the fraction. Multiply both sides by e to the x. So right-hand side's easy. 5, like that. Left-hand side, e to the x times e to the x.
2 e to the x.
It's not 2 e to the x.
It's e to the x times e and squared.
So there's a couple ways you could write it.
E to the 2x.
Both of those are right. It's e to the x squared which is the same thing as e to the 2x.
You go natural log both sides. Move the 2 over and cross those out.
And we'll natural log both sides, because that will get the 2x out of the exponent.
Divide by 2, x equals.
So natural log of 5
2.
divided by 2.
C.
That's not the same as c, though.
Never mind.
The natural log of 5 divided by 2, not the natural log of 5 over 2.
Oh.
So,
So it's
which,
B.
yeah, if you don't like divided by 2, and maybe what would be better if you multiplied both sides by a half, 1/2 natural log 5. That's the same thing. So you need to be able to recognize that,
Because it can't.
that those are the same thing. You can't slide that 2 into the argument. All right, let's put that aside and get to the new stuff for today.